let's start with our cumulative practice problem 1A. A group of KAC scholars are getting on the Twisted Cyclone at Six Flags Over Georgia. If you don't know, the Twisted Cyclone is a ride that drops scholars while spinning them around, or drops people while spinning them around on the roller coaster. But it is basically a single direction roller coaster. The mass of the riders is 9,000 kilograms. So that is a mass, as well as the train. So that's the little car that everybody gets on, is 15,000 kilograms, which is also a mass. Okay. The ride at its maximum height is 760 feet. That is our height, but we also know that we're going to need to convert that value. Okay, it needs to be in meters. The ride reaches its top velocity at 1.5 minutes, which is our time that also needs to be converted. All right, so the question asked us 4 different things to calculate for throughout this problem. The first thing is, what is the potential energy? The second thing it says is it tells us, since the potential energy transfers to kinetic, that's an important piece of information, calculate the velocity of the train. So here it's asking us to find velocity. Then the next one is saying to calculate the work required to move the train. So this is asking us to solve for work. And then finally it says, what is the power produced by the rider? Thus, it's asking us to find power. Okay, so what the first thing I like to do before I even start to calculate is go through my given information and identify what I do and I do not have. So I'm going to make a real small key right here at the top with the information that was given to me in the problem. So within the problem, the first thing I noticed that they gave us 2 masses. They gave us the mass of the riders and the ride together. Well, I know that when I get on a ride, it doesn't leave me behind. We come together and become one. So I need to figure out the total mass of the ride and the rider. So I'm going to add 9,000 and 15,000 to find that my total mass is 24,000 kilograms. The next piece of information that they gave me is the height or displacement. In order for me to find height or convert this height that they gave me, I'm going to take 760 feet and convert it to meters. So I'm going to do a quick conversion. I'm going to end up erasing this because by now we should know how to do quick conversions. But 760, my conversion is going to be 3.281 feet in 1 meter. And when I divide those 2 numbers, I'm going to get a number with a lot of numbers behind the decimal, but I'm going to go ahead and round it. So I get 231.64 meters. So the height, once again, I'm putting this in my key, is 231.64 meters. Okay, but this was the conversion that I did to get this value. All right. And then the last piece of information that they gave us within the problem is time. Time is given to us in minutes, but we know we need to convert that to seconds. And hopefully we can do a really quick conversion there. We know there are 60 seconds in 1 minute. So if I take 1.5 and multiply it by 60, I will find that the time is 90 seconds. So of all the information that's given to me in the problem, I only know 3 values, but perfect, because for part A, that's exactly what I need. I need most of these values that are given to me here. So A tells us to solve for potential energy. All energy is measured in joules. And the equation for potential energy is mass times gravity times height. Well, like we just figured out, the total mass of the ride and the riders is 24,000 joules. Gravity is a constant value that we should know by now at 9.81 meters per second squared. And then height, what we just converted, was 231.60 4 meters. So I'm literally going to take these 3 values, plug them into this equation. I'm solving for potential energy, so I'm just going to bring down that variable is equal to 24,000 kilograms times 9.81 meters per second squared times 231.64 meters. In my calculator, I'm going to multiply 24,000, 9.81, and 231.64. When I multiply those 3 numbers together, I'm going to get a really big number because I'm working with really big numbers. So don't be alarmed when your number is really large. When you multiply, just know that the number is going to get bigger. So I'm going to get a really, really big number. 54,537,321.6 joules of energy. All right, so here is our first answer for what potential energy is. Now let's move on to the next question. The next question asks us to find velocity. A key thing that they tell us here in the problem is, since the potential energy can transfer to kinetic energy. This is a key phrase. So when we're reading our questions, we should be paying attention to words and key things that they're telling us. They're telling us that we are going to be able to take this potential energy and use it as kinetic. This means that there's that much potential energy stored up at the top of this ride so that when it drops, all of that velocity, all of that potential energy is converted to kinetic. So for part B, we're going to use this potential energy and convert it totally to kinetic energy to help us find velocity. We're going to use the kinetic energy equation where mass is being divided in half and velocity is being squared. Our kinetic energy, remember, we're just going to use this value that we just got for potential energy, 54,537,321.6 joules. And then our mass that we've been using, that's combined together, 24,000 kilograms. Okay, so let's substitute in, starting with our kinetic energy value. And then it's equal to, well, I can do some quick math here. I know that half of 24 is 12. So half of 24,000 is going to be 12,000 joules. That way I don't have to sit here and write that out when I can do some quick mental math or even type that in the calculator really quickly instead of sitting here and actually writing out the full mass divided by 2. I just went ahead and divided the mass in 2 and plugged it in here. And then I'm just going to bring down my unknown with the squared. Do not forget to bring down the squared. It didn't just drop away. We have to get rid of it using opposite operation. So let's start with our first opposite operation. If 12,000 joules is being multiplied by velocity squared, the opposite operation is to divide 12,000 by both sides. When I divide 12,000 by both sides, I will find that my new value, and I'm going to keep all of the numbers because it's not a final answer, is 4,544.7768. This is now equal to velocity squared. But the question doesn't ask me for velocity squared. It asks me for velocity. So in order to get rid of this squared up here on top of the velocity, I'm going to do the opposite operation of squaring something, which is to take the square root or put it under the radical. When we take the square root of this number, now we are going to round because it's our final answer. We will get 67.41 meters per second as our velocity. All right, we're almost halfway done with this problem. I'm gonna highlight my answer like I did with the last one. We are halfway done with this problem. Our last few steps, we have to do a little bit more work for part C. Part C is asking us to find work. But when we think about the work equation, the two variables that we must know to find work are force and displacement. Well, we know the displacement because that's the height of the roller coaster. So displacement and height are the same thing because they're both measured in meters. But what we don't know is the force. In order to find force, we need to be able to multiply the mass and gravity, which is going to pull the ride down or cause the acceleration of the ride going down. So we're going to have to do two calculations here. The first one being to solve for force, using our force is equal to mass times gravity equation. Using that same mass we've been using this whole time, 24,000 kilograms, and then gravity is a constant 9.81 meters per second squared. I'm going to take this value and I'm going to multiply these two together. So force is equal to 24,000 kilograms times 9.81 meters per second squared. When I multiply these two numbers together, I get 235,440 newtons. But I am not done. We know that we didn't actually answer the question just yet. We need to use this force to find what the question is really asking us for, which is work. Work is equal to force times displacement. Now we know our force from what we just calculated. And once again, our displacement is the same as the height of this roller coaster. Because this is a roller coaster that is dropping, we know the height or displacement. However, if this was a roller coaster that goes up and down and round, we would actually need to know the length or how long how long the ride was to find the displacement. But in this case, our displacement is the same value as our height. All right, so our displacement for this, once again, is 231.64 meters. So we're just going to multiply these two numbers together. And when we multiply these two numbers together, we will find that the work done looks like a number we've seen before. 54,537,321.6 joules. If you're paying attention and if you identified that this is the same value as our kinetic energy, our potential energy and our kinetic energy, you are correct. This is true because once again, as I emphasized while we just did this calculation, work in this case is going to be the same work done to drop the roller coaster. So the potential energy that it was stored up at the top of the ride and the kinetic energy it takes for it to drop to the bottom is the same as the work that is going to be done. This is not always true in every case. So I want you to keep in mind as you're working that potential and kinetic energy value will not always be the same as your work value. Okay, but in this case, because the work is in a single direction, all of the kinetic energy, potential energy, and work done value will be the same exact number. All right. So our last step here, part C, asks us to solve for power. Now we have all the information we need to solve for power because we needed to know the work in order to find power. Power is the rate at which work is done. So we're going to do work over, not two, over time. We just got our work value. And then the time has not changed. We're still working with the same 90 seconds that it took for the ride to drop. Okay. Power equals 54,537,321.6 joules over 90 seconds. I'm going to divide these two values by one another to find the rate at which the work was done. And we're going to find that that is 605,970.24 watts? Well, when we learned about power, we learned that power done by machines and things like a roller coaster is a machine is better measured in horsepower versus watts. So what we're going to do really quickly is convert this to a number that makes a lot more sense. We're not talking about energy from like a light bulb or energy to make some type of electronic device work. We're talking about a machine that is requiring all these different things, the locomotive things to happen. And so we want to convert this number to horsepower really quickly, just to make sure we have a better understanding of what this value actually is. So we're going to take this number, and if you remember the conversion factor to go from watts to horsepower, we're just going to divide 745.7 by our amount calculated to get this into horsepower. When we divide 605,970.24 by 745.7, we will find that our power value in horsepower is 812.62 horsepower, which is a more realistic and understandable number when we're thinking about a machine. It's large, it's still big, but it's better makes sense about all the different mechanics and things that go into play when we think about our values. All right, so go ahead and pause the video, answer your questions, and move on to 1B on your own.